Now I have placed the wall in the right position. So the structural wall layer, the concrete masonry unit, it's matching the center of the steel structure, beams and columns. That's a good strategy. Okay, so this is what I would do always. If we have a structural layer, and make sure that this layer matches the axis of the structure of the steel structure. Make sure that the thermal insulation is continuous. Make sure that the thermal insulation is not interrupted by the steel structure. And then you need this air gap. It depends. If this steel structure is wider, then you need to increase probably this air gap. Okay, so that's fine. But the important thing is that the 5-inch thermal insulation is not interrupted by this structure here. But as you can see, we have some issues, especially here, and here we have a corner. What if we create another wall like this one in this corner? Let's do it. So I'm going to go to wall, and I'm going to the same wall. Start here, and we go this way. Okay, so first I have to do the same. I have to move. I have to make sure that the center point of the concrete masonry unit is here. Okay. So now the thermal insulation is not interrupted in this corner. That's fine. But look at this. I have a concrete masonry unit that it's going through. That's impossible. Okay, so when we have a structural element, a steel structural element, I have to interrupt the concrete masonry unit here. And sometimes, to make it even more efficient, I fill all these with a. It's can be a thermal insulating material, or it can be a waterproof material. Okay, so this steel structure is covered by this material. Like this, you see. So this is a steel structure, and it's covered by this foam. You cover all this steel structure with this. It protects. It provides some thermal insulation, and it protects the steel structure against fire. Okay, so usually when we have a steel structure, we have not placed the wall yet. We apply foam here. We cover all this with the fire protection layer, and then we have we start placing the rest of the layers, the concrete masonry unit. Then that there will be something like this. So there will be something covering that structure. So I have to interrupt this. I have to interrupt this because I can't go through the steel structure with my concrete masonry unit. So this is what I want to do in this Revit file now. And to do that, I have to work with parts. If you select this wall, we can differentiate between different parts now. Okay, so this is what we are going to do in this tutorial. We have to select the wall, and you see here that we can create parts. Okay, so creating parts make all these layers independent. So let's do it. Create parts. And now if we do this, you see that we can select the gypsum, we can select the air layer, the concrete masonry unit. So we can select different layers here. So if I have to interrupt this, I can select the concrete masonry unit. You have to click here, show shape handles, click here, and now we can drag this element there. Okay, you see what I have done? I have selected this element, and if this element cannot go through the steel structure, I select this show shape handles, and then I can drag this so that the steel structure is free from that. I can do it here too. Like this. And with the thermal insulation, I don't have this issue because I want it to go through, or yeah, I don't want to interrupt it. Okay, so I'm not changing anything. But when it comes to the concrete masonry unit, I have to make sure that it doesn't go through the steel structure. How does it affect the 3D view? So on the 3D view, well, you see that we have the wall, but we can't select the parts in this wall. I can select the steel structure, but in the 3D view, you can't select parts. You can just select the wall. If you select the wall, the create parts option is disabled. So what can I do? Well, I don't know why, but by default in Revit, parts are hidden. Okay, so if you click here and hide elements, and if you select all these, here you can see the parts. You can see the different layers, the concrete masonry unit, all that stuff. So make sure that you select everything, you unhide in view category, because if you unhide parts, and then you click here again, now you can select the parts in the wall. You see? The same thing with the section. In a section, you can select the wall, but you can't select the parts. And create parts is disabled. So it's again, they are there, but they are not visible. So you have to go to here. You have to select the parts and hide in view category. And then we can select the parts. And we have to do the same. We have to select the concrete masonry unit, and the concrete masonry unit cannot go through the steel beam. So we have to drag it here. Okay, so now the concrete masonry unit is not going through this element. It can start here because it's just leaning on the floor slab. So it starts here, but it doesn't go through the beam. Well, once we have this, that's great because we can select different parts. Imagine that we are selecting this part in a 3D view, and I can show shape handles, and then I can select different parts, and I can show different materials. Probably using hidden line would be easier. And I want to select this part here, but it doesn't. Oh, no. Okay, so you can see that here you have different layers, and then you can show different layers here. You can show the aluminum, you can show the air layer, the thermal insulation, and the concrete masonry unit here. The problem is that when we select this, we can see through it because it becomes transparent. But if it's not selected, I can't see that. Why? Because I have the wall. Okay, so I'm working here with the wall and with parts. If I want to get rid of the wall, I have to select the wall and I have to hide it in view. And now I can see all these layers. And that's very useful because I have an axonometric view and I can do this and I can say, okay, this is aluminum, this is whatever, this is the thermal insulation, and this is the concrete masonry unit. So I'm just looking at all the layers I need in this. And for sure, in the 3D view, this concrete masonry unit is not going through the beam. It has been stopped because I did that in section. And if I move the first section here, since I'm working with this wall, if I move this section here, what am I going to see? I'm not going to see the thermal insulation and that in this section too. Well, I see because it's beyond that, but it's not section. Okay, so the good thing of working with the 3D is that if I have another section, I keep looking at the same materials and I can select all the layers. Okay, so we are not working in a 2D document. We are working as a 3D wall, and as a 3D wall, I can show different things. And I can do wonderful things here because if I decide to, I can drag different layers so I can understand how many layers I have in a 3D view, or I can explode. If you do this and if you click displace elements, you can displace all layers. And then we can have this path like this or like this. Okay, so there are a lot of things we can do in a 3D view to define different materials. And that's useful because we can work with we can do things like this. Okay, so we can explode something and we can define what we have inside by, or we can do drawings like this one, but defining all the layers that we have in a construction. Let's see an example. Yeah, so from the construction point of view, you can define the structural elements, the envelope, the thermal insulation, the roof, the wall on the same picture. So that's very useful, and it's always very nice doing something like that. Okay, so to do this, we have to work with layers. So we have done this. Now we have different layers. The problem is, imagine that you want to include a wall. Oh no, you want to include a window on this wall. So I have a window. I changed my mind and oh, I wanted to create a window here. I can't. You see, I can't include a window here because I have divided this in parts. So I recommend you do this when you're sure that your picture or your model is finished. Okay, so start working with the layers, parts, explode them, drag them to show different materials. But if you are still designing, don't do that yet. Okay, so that would be the final stage of the process, defining the construction. Because if you change your mind and you decide that you need a window here in that wall, you can't do it. So I'm doing things. Okay, so that's the beginning. No, this is not the beginning. And I want to show the wall. So I want to do this and hiding view. Look. Oh, probably the wall is there. Yeah, we could have walls. Okay. Yeah, so now we have the wall there and we have the parts. You see that we can select the wall or we can select the parts. So this is the wall. So when we have this, when we have wall and parts, and I change my mind and I want to include a window, I can do it. But when we are hiding the wall, then we can't include the window. So I want to do something more. It's not just working with a window. I want to do something better because if you see these Alucobond details, okay. So there's a relationship. There is always a relationship between openings and panels. You see that this line continues here, and the size, the width of this panel is the same as the width of the curtain wall. Well, we are architects. We should do that. You see in this facade, again, we have vertical lines, and the same vertical lines we have in the curtain wall, we have in the Alucobond panel. So if we are good architects, we don't design Alucobond panels, whatever size, and then we place a window like that. Imagine that we are designing a wall. We have divided this into panels. And then I say, I need a window. Oh, let's place a window here. And let's do this. This is not acceptable because each panel is a different size, and that will cost a lot. Okay, so when we are working with this kind of modular facades with panels, we don't do this. We divide the facade with the size of the panel. And if we need a window, just take up the space between panels. And then you can design a window here. Okay, so this is what we are going to do now. We are going to divide this finish, this aluminum finish, in different layers. And then we're going to adapt the size of the window to the size of those panels. This is what we should do as architects. Okay, so first we have to divide this. We can decide, we can tell Mr. Alucobond, okay, I want panels this size. As long as most of the panels in my building are the same size, that's fine, because they only have to put that number or that size in their machines, and they manufacture thousands of panels. The problem is, no, this panel is 5 inches by 8 inches. No, I need another one, 5.5 and 8.25. No, and another one is, that's crazy, and it costs a lot. Okay, so if you have a building like this, especially if we're working with grid lines, if we're working with modules, we can decide what the module is, and then we manufacture thousands of panels with the same size. So that's saving money. So let's do it. First, we decide how we want to divide this. I don't mind, you can do whatever you feel like. I'll show you how to do it, but you can decide how many parts or how many panels you have in this wall. When we are dividing things, well, the corner is something special. So I would divide, if we have grid lines and all the grid lines have the same distance, this is what we have done here. So I will start with this grid line, and then I will finish with this. And how many vertical partitions do we want? Let's say 4. And I would use reference planes. Okay, so let's use a reference plane. The first reference plane is going to be here, matching the grid line. And then randomly, I select one reference plane, another one, and another one. Okay, so there will be 1, 2, 3, 4 vertical partitions. If I want all these distance to be the same, I have to do it with annotation. Annotate, align. We select the first point, the second, the third, the fourth, and the fifth. We drag all these dimensions here. I press EQ. And now all these elements are at the same distance. Okay, I have created a reference plane, 1, 2, 3, 4 reference planes, and all of them are the same distance. The problem is that reference planes, I need to name them because if they don't have a name, you see that by default, they don't have any name. So they don't work. So I want to name them. So I have to select the reference plane here. If it's not selected, I select the grid and this filter reference plane. And now this name is vertical 1. Okay, this is vertical 1. This is vertical 2. Vertical 3. And vertical 4. Okay. So we have divided this into 4 different planes. Now, horizontally, what would you do? We have to do that through the elevation. What elevation is this? South? Yeah, I think it's the south elevation, but it's not showing up here. Yep, look at this. If you change to the elevation view and you don't see the wall, what happens? Don't panic. It's because we're in a structural discipline. So let's change to architectural discipline, and then the wall, it will show up here. And here we have the vertical reference planes. You see, 1, 2, 3, 4 reference planes here. So now we have to divide this horizontally. How? How many panels we want here? Let's say 4 again. So we have to work with reference planes. I'll create the first reference plane here, aligned with the level, and I'm going to filter reference plane, and I'm going to name it horizontal 1. Okay, and then randomly, I'm going to work with another reference plane, this one. Make sure that you have to go beyond the element that you want to divide. Okay, so don't stop at the reference plane in the middle of the wall. And then I need another one. Another one here. And finally, the other group here. Okay, so name them. This is horizontal 1, this is horizontal 2. Horizontal 3. Horizontal 4. And we can select this filter plane. That would be horizontal 5. Okay, now we want to make the distance, we want to make the same distance, annotate, align, click here, click EQ, and now we have a grid. Okay, so we have this grid, and all these panels are going to be the same. And I'm going to create a window here, just in the middle with these 4 panels. I want to create a window there. Okay, if I want this window, I need to know the dimensions. Okay, so I need to align. I need to take this dimension, 12 feet and 7 inches, and this dimension is 7 feet and 6 inches. So now I'm going to create a window with this size. So I go to architecture, window, I edit this type, and I'm going to duplicate, and the name of this window is 12 and 7, 12 feet 7 inches by 7 feet and 6 inches, 7 feet 6 inches. Okay, and I have to change the actual dimensions. The height is 7 feet and 6 inches. The width is 12 feet and 7 inches. 12 feet 7 inches. Okay, and now the window matches this. So place it somewhere and then use align to make sure that it's in the perfect position. But then on the 3D view, I'm going to use a hidden line because it's better. We don't see the parts yet. Okay, so we have included, we can select this layer, but we don't see the different panels. How can we actually divide it? In the elevation, we can see that it's correct. We have the panels here, but we can select independent panels. Okay, so let's do it in 3D. Let's select just the layer. Don't select the wall. You have to select only the layer that you want to divide. Okay. Now you can click here, divide parts. Select, divide parts. And now we have to select intersecting references. That's why we have created the reference planes, because now we can use reference planes as entities that are dividing our wall. So select intersecting references. And here you can use levels, you can use grid lines, or you can use reference planes. I'm going to use reference planes. And now select all the planes that we have created. Click apply. And click OK. And now you see the different parts, and each part is independent. This is higher level stuff. Come on. So it's not just a wall, a window. No, we are doing something meaningful.